What if I told you there's a way to solve a whole class of super tricky string problems in linear time, just by moving 2 pointers? Well, let's dive in, because today we are mastering the sliding window. It's going to be your secret weapon for absolutely acing those substring questions in coding interviews.
You've been there, right? You get a string problem and your brain immediately jumps to nested loops to check every single possible substring. And yeah, it might work for a tiny example, but you get that sinking feeling, that this is way too slow and it's never going to pass on a large input.
Well, here's the good news. You can officially leave those clunky brute force solutions in the past. There's a much more elegant and, more importantly, a much faster way to tackle these problems. And that is exactly what we are going to break down right now.
So let's pull back the curtain on this better way. Seriously, this is a technique that's going to completely change how you look at a huge category of interview questions. Okay, so here's the textbook definition. A sliding window is all about using 2 pointers, usually called left and right, to mark out a specific chunk or a window over your data. The whole idea is that this window slides. It expands by moving the right pointer, and it shrinks by moving the left one, so you can check all the important parts without redoing a ton of work.
To make that way more simple, let's use an analogy. Just picture your string as a long ribbon with letters on it, laid out on a table. Your 2 pointers, left and right, are basically just 2 little markers you put down on that ribbon. And the part of the ribbon between those 2 markers, that's it. That's your window.
All right, so we have our window, but how does it, move? Well, it's all about this really simple rhythm. You expand, and then you shrink.
The whole process is basically these 5 steps. First, you start both pointers right at the beginning, at index 0. Then, you start expanding the window by nudging that right pointer forward. After every single move, you check, is my window still valid? Does it meet the rules of the problem? If the answer is no, like maybe you have too many duplicates, then you start shrinking the window from the left until it's valid again. And you just repeat this expand, check, shrink dance all the way to the end.
This brings us to a really important idea, the invariant. Think of the invariant as the golden rule your window has to follow at all times. For example, the rule could be, this window can't have more than 2 distinct characters. This rule is your signal. It tells you when it's okay to keep expanding and when you have to start shrinking. So what kinds of problems does this actually solve? Well, it turns out most interview questions that use this fall into a few really common patterns. Let's check out the big ones.
The first pattern, and probably the most common one you'll see, is all about finding a window with the best possible size. The question will be phrased like, find the longest or find the shortest substring that follows some rule. The window size is always changing, and your job is to keep track of the best one you found so far.
So you'll get these classic questions like, find the longest substring with no repeating characters, or the really famous one, find the minimum window that has all the characters from this other string. In all of these, you expand to find answers, and then you shrink to make sure your window is still valid.
Now, the second big pattern is a little bit different. With this one, the window size is totally fixed. You're not trying to find the longest or shortest anymore. You're just sliding a window of a specific, constant size across your string and checking each chunk to see if it's a match.
The absolute classic example here is finding all anagrams. Let's say you're looking for anagrams of a 3-letter word. You just create a window of size 3, slide it across the bigger string 1 spot at a time, and for each position, you just check, hey, do the letters in this window make an anagram? It's super clean and so much faster than the alternatives.
So, we've been saying this technique is fast, but why is it so fast? The performance is the real magic here, and it's the reason interviewers love seeing this approach.
It all comes down to this. A good sliding window algorithm runs in O of n time. That's linear time where n is just the length of your input, and that, my friends, is a massive, massive improvement over brute force.
And here's the simple reason why. The right pointer, it moves from the start of the string to the end exactly once. And the left pointer, it also only ever moves forward. That's the whole game changer. You're never going backward, you're never rechecking the same character combinations over and over again. Since every character is only visited by the pointers a couple of times, the total work is linear. Boom, O of n.
Let's just put that into perspective. A brute force O of n2 approach blows up and becomes useless as the string gets longer. But the O of n sliding window, it just scales perfectly. It's literally the difference between an algorithm that times out and an algorithm that gets you the job.
Okay, the theory is cool and all, but how do you actually use this to blow away your interviewer? See, it's not just about getting the code right, it's about how you explain your thought process.
Here are the talking points that make you sound like a pro. Start by clearly stating your window's invariant. That's the rule. Then talk them through your logic. I expand the window to find a potential solution, and I shrink it whenever I break my rule. And then the clincher. Explicitly state the ON time complexity and tell the why, because each pointer only makes one pass over the data.
And just as crucial, here's what to watch out for. Remember, a substring has to be a continuous block of characters. Be super careful with off-by-one errors when you calculate length. It's almost always right minus left plus 1. Oh, and if you need to count characters, use a hash map, not a set. A set will just tell you if a character is there, not how many. And of course, always think about the edge cases, like an empty string.
So, we've seen just how powerful the sliding window is for strings, but the core pattern itself, these 2 pointers defining a dynamic chunk of data, is so much more general than that. Which leads to one final thought. What other things, like arrays or lists, could you apply this very same expand and shrink logic to? Once you see that, this technique stops being a trick for strings and becomes a fundamental tool in your entire problem-solving arsenal.